All right, class, today we're going to be looking at standard deviation. So the standard deviation is something that we should include in this instance in the RAC portion of our IA practice. So the RAC, remember, is results analysis and conclusion. So specifically this should be with the analysis. So that's when we're taking the data and we're trying to make sense of it. So the analysis is going to include a graph with a line of best fit, taking a look at the R-square value to see how well the data fits our line, and then the standard deviation. So the standard deviation is going to tell us how spread out our data set is. So we're going to look at this, what it means, and then take just a quick look at an example. So why do we want to do this is the first question. So really why, okay, if we're looking at why, this tells us if our data is, so number one, and in all cases it'll tell us if our data is precise, so if the numbers are very consistent. Okay, so if they're coming in very close, if they're close to the mean, then that's an indication of precision. But in our case, because we all did the same, we did the same lab as well, it's going to also indicate a bit about accuracy, because if we all did the same lab, theoretically there should be one right answer. There should be a time in which the solution at the temperature of the classroom would lose oxygen and become anoxic, or hypoxic, or whatever. So we are trying to figure out, okay, the precision and the accuracy. So in our case, was it accurate? It was not accurate. And if the data is super spread out, then it's probably not super accurate. So if we look, standard deviation is a formula. So I'm going to write SD for standard deviation. That is equal to the square root of, okay, so we're going to add that sigma. Oh, it's ugly. It's an ugly sigma. X minus X bar, okay, squared over n. So let's look at this. So X is the number or data point. X bar equals the mean or the average of the data set. N is the number of samples. And then just as a reminder, sigma is the sum. Now, there's a few different ways we can calculate standard deviation. So we can do a standard deviation for all of the samples within the set, or we do like a population standard deviation, in which case we do n-1 at the very bottom, and that's to account for unknowns. But for now, we'll just do our example this way. Perfect. So to set it up, what we are going to see is that, here, I'm going to draw a little graph. So first we need to calculate the mean. Okay, so I'm going to draw a little bar here. So this line is going to represent the X bar, or the mean that we're going to calculate for all of our data points. Then if we look at the standard deviation, really the standard deviation is giving us like a range of numbers. Okay, so it's giving us a range, and we can look at a standard deviation below the mean and above the mean. And when we calculate the standard deviation, we're saying that 2/3 of our data points will fall somewhere within this range. Okay, so we'll try and figure out what that is based on our calculation. So step one, if we're going to do this, and in your IA, I would do an example by hand just to show that you actually know what this means. So if you're going to do it, I would do it by setting up a data table. So I would set up a data table with my X value, so that's my data point. my x bar, okay, my x minus x bar, and then my x minus x bar squared. So when I do this, you should take all the numbers that are available within the data set for your IA and for your practice IA as well. But for me, what I'm going to do is I'm just going to take the first three for the sake of the example. So let's say I look and I wrote some down here, so I'm just going to grab what I think I see from the data. So I think one point was 346, then 586, then 432. Okay, perfect. So the first thing I need to do is calculate x bar. So I'm going to grab my calculator. Okay, so on my calculator, I'm just going to add those things together. So here we go. Got 346 plus 586 plus 432. That's going to give me this, hopefully. And then there's three numbers, so I'm dividing by 3. So I'm just going to round to the nearest whole number. Is that right? Let me see. I hope so. I'm just going to round. Okay, so I'm going to 455. 455 and 455 because the mean is the same. Okay, since this is the same data point. Now I need to take x minus x bar. I'm going to clear. I'm going to go 346 minus 455. Okay, so that's going to give me negative 109. Okay, then 586. Oops, make sure I'm deleting. 586 minus 455. 131. And then clear that. 432 minus 455, negative 23. So our next step is to square that number, and squaring that number actually will get rid of any negatives. Okay, so we're going to take, you could write negative if you want, negative 109, but I know that the negative is going to be gotten rid of anyway, so 109 times 109. Okay, it should be negative 109 times negative 109, but a negative times a negative is a positive, so you should know that hopefully from elementary school. Okay, so then I'm going to put in 11881, perfect. Then delete 131 times 131. Okay, so we've got 17,161. Then, okay, again, negative 23 times negative 23, but I know that that's going to be eliminated anyway. So here I'm getting 529. Okay, perfect. So that's my first step, is just to look at all the data points within the data table. Then 2. Okay, so take the sum. We're going to sum x minus x bar squared and divide by n. Okay, so now I've got 529. I'll put this up here. 529 plus 11881 plus 17,161 equals, okay, so I'm writing 29,571. We're dividing by the number of samples, which is 3, and that's going to give me, I said double check, times 3 equals, okay, divided by 3. Okay, 9,857. Okay, perfect. So then step 3, we're going to take the square root. So now we're going to take the square root. So remember, this is really the square root of the sum of the last column numbers divided by n, but we did all of those other steps separately. So now here we are. We're taking the square root of 9,857. Okay, square root button. This is where things get interesting. Okay. I'll flip it over so I can get more operations. So square root 9857. Okay. So this is giving me 99.28, etc. So I'm going to keep a decimal place, I decided, so I'm just going to go with 99.3. So our standard deviation is, oops, I feel like you can't really see my screen, but that's okay. When we calculate it out, okay, our standard deviation, it should be just under 100. So let's see, maybe I can make my screen a little bit darker. At this point, I guess it doesn't really matter. You can definitely calculate these numbers on your own, and with the example, you'll be totally fine. So now we've got our numbers. So I got 99.28, but remember, I only used 3 of them, and in reality, I think you have 6, so you'd have to do all of them. So now, what is this telling me? So I've got 99.3. Okay, so it's telling me that if I look at the mean, so our mean was, I wrote here x bar. I'm just going to redraw this actually at the bottom. Whoops. My little curve looks a bit different, but that's okay. So my standard deviation, my x bar was 5, oops, not 5, was 455. Okay, so it's telling me that 2/3 of my numbers should be within 1 standard deviation of the mean. So this would be 455 plus 99.3, okay, and this would be 455 minus 99.3, and that 2/3 of my value should fall into this category. And it doesn't matter how many points you have. So in this case, we're looking at 3 points, but if we're looking at, thousands of points, that 2/3 of them would fall in within 1 standard deviation. So telling us again how spread out they are. And remember, this is all in seconds. So we're saying that 99.3 seconds. Okay, our average was 455 seconds for whichever data point I chose, and I can't remember which one this was. But that means that all of our tubes essentially would have changed color within this range. And remember, this is our mean. So we're 99.3 is a minute and 40 seconds. So we're going a minute and 40 seconds over the mean and a minute and 40 seconds under the mean. So depending on what it is, we can decide, is that reasonable or is that too much? Okay, so trying to figure out our accuracy and precision of our results, given the fact that if we all did this under the exact same situation, the same circumstances, ideally there would be one very narrow correct range. Okay, so just thinking about that information and analyzing it, and that's what the analysis portion is all about. So I'm going to have you give this a shot. I would do it by hand because you're going to be typing your IA, but in reality, in your IA, you should show what the formula is for the standard deviation. You should be discussing what it means, and I think it would be wise to show a sample calculation just to see how well, just to show that you know what you're doing, okay, and that you understand the calculation as well. So again, here we calculated all of the samples, but in some cases you might take one off, and the results really, it doesn't totally matter because we're still just looking at the accuracy and the precision of our results. So there's 2 different ways to calculate the standard deviation. So we're going with this for our example today. Okay, so good luck. I will post the rest of the information soon. All right, bye.